In the next few videos, we're going to learn about the distributive property. So first, let's look at the distributive property in arithmetic so we can make sense of this using numbers, and then we're going to apply it to algebra. Okay, so let's read the problem. Polly has a rectangular flower bed that is 10 feet long and 4 feet wide. Okay, so here's an image of the flower bed. We're calling this the length, and we're calling 4 feet right here the width. She is going to plant morning glories and tulips. She wants more morning glories and tulips and decides to divide the garden as shown below. So notice above, this area right here, which is in pink, is the tulips. That is 3 feet on this side and 7 feet for the morning glories. And notice this side right here is equivalent to this side, so it's also 4 feet. Okay. So now recall, we're going to find these areas, the areas of the individual parts and the areas of the total. And remember, finding an area means counting the number of, in this case, since we're working with feet, the number of square feet that would fill up this region and cover it without overlapping. And we can do that via multiplication. So the first one says, determine the total area of the garden by multiplying its total length times its width. So that's going to be 10 feet times 4 feet, which is 40 square feet. Next, we're asked to determine the total number of square feet that will be planted with tulips. So this region is tulips. It's also a rectangle, and it's 3 feet by 4 feet. So 3 feet times 4 feet equals 12 square feet. Part C, determine the total number of square feet that will be planted with morning glories. So its dimensions are 7 feet by 4 feet for the morning glories. And 7 feet by 4 feet equals 28 square feet. Part D, determine the total area of the garden. And notice we've already done this in part A, but we're asked to do it in a specific way by adding the area planted with tulips and the area planted with morning glories. So, looking at our last two answers, if we add the tulips plus the morning glories, that equals the total area of the garden. So 12 feet squared plus 28 feet squared, which gives us 40 feet squared. And notice this corresponds to our first answer, which shows that it's consistent. Now part E, using the equation below, describe in words how it represents the two ways we found the total area of the garden. Okay, so here's our equation. Now the left-hand side, remember this 12 feet squared and 28 feet squared, we got from these computations. So the 3 feet times the 4 feet, that was the tulips. I'm just going to put T for tulips, or the area of the tulips. Okay. And 4 times 7, well, that was the area of the morning glories. So I'll put M for that. Okay. So we can add these two amounts, and it equals the total area of the garden. Okay. Now on the right-hand side, that doesn't look identical to how we found the area of the garden. Remember, we found 10 feet times 4 feet. And remember, because of commutativity of multiplication, we could write 4 feet times 10 feet, and that's equivalent. Okay. So here we have a 4, and in parentheses, we have 3 plus 7. Okay. So now remember, even though multiplication comes first, when we have parentheses, that trumps the multiplication. So first we'd add 3 and 7, which is 10. Well, that corresponds to the entire length of the garden and 4 feet wide. So this is the total garden, looking at the two quantities combined. Okay. Now, this is going to be a very important property for us for algebra. So let's sum it up using arithmetic on the next slide. The distributive property of multiplication over addition, and it also works for subtraction. Here are some examples. Okay? This may look familiar to you. If you have 4 times the sum of 3 plus 7 in parentheses, you can find that quantity. It's equal or equivalent to multiplying the 4 times the 3 and then adding the 4 times the 7. Okay, so this is what we did. This is the total garden. The 3 plus 7 was 10, but we can split it up and think of finding the sum of these two products instead of the product of this number and the sum. It also applies to subtraction. So if we have 3 times the quantity of 6 minus 4, or the difference, we can multiply the 3 times the 6 and then subtract 3 times the 4. So in the next video, we're going to work on this same type of problem, but we're going to apply it in the algebraic context.